I'm Anil Kumar. Let me thank all the viewers and subscribers for watching my videos, posting excellent remarks, and sharing some questions. One of the major use of my YouTube channel is really to help you solve or understand the concepts. So normally I'm not posting many videos on physics, but I thought I should take it since it has been posted, right? Okay. So, Mr. Nihal, I hope this solution will help you. I'll make it simple. I'll not use a lot of physics language here, but I'll focus on mathematics of this, okay? The question here is, Jack, the senior instructor at Norman Butler School, is educating two novice food educators, Mattis and Alex, on how to carry 5 kg tray ladder on one hand. Carrying the tray 170 centimeter above the ground, Mattis walks forward at 5 kilometers per hour and stumbles, sending the tray and the content down forward. Alex, who was also walking beside Mattis, dives forward and downwards instantaneously in an attempt to catch the tray before it hits the ground. Now, based on this situation, we have three questions. How long would it take the tray to hit the ground? That's the first question. What is the horizontal distance traveled by the diving Alex? And the third is, what was kinetic energy of the loaded tray just as it reached the ground? Okay, so let us see how to solve these questions. First, let's try to understand the basic concept, right? So, I'm just making showing the situation of the tray with the help of a diagram. So let us say this is the time when the tray falls. So it will actually follow a parabolic path as being shown here. So it has been stretched out to just show the things clearly. So what we have here is the height is 170 centimeters. Now you should follow one system of units, right? We'll follow MKS system, right? MKS system means mass will be, height will be in meters and the mass will be in kilograms, right? So we'll convert this 170 centimeters to meters. So that is kind of important. So the height is 170 centimeters. Dividing by 100, we get 1.7 meters. So that becomes the height from which the tray is falling. Now, the forward velocity is given to you as 5 kilometers per hour. So this tray is going to move forward in this direction with the velocity of 5 kilometers per hour, right? We are also given that the mass is 5 kg. So I'll write down this mass right here. We'll say mass M of the tray is 5 kg. Now, very important to understand is, since the last part is about the energy part, we have to understand conservation of energy. That is one very important thing. So the energy remains same in both the points, right? Initially when the tray is being carried and later when it falls. The difference here is that the potential energy, which is because of the height, has been now converted to kinetic energy. So the kinetic energy increases. Correct? So the last part, what was the kinetic energy of the loaded tray just as it hits the ground, will be initial kinetic energy plus initial potential energy, right? So at this point, we have full potential energy due to the height of 1.7 centimeters. Is that clear to you? So that is how you're going to answer the last one. Now here, how long would it take the tray to hit the ground? So basically we need to find time when the tray is in the air, right? So that means we need to find time when it is in the air, time in air. Second question is, what is the horizontal distance by the diving Lx? Now once we find this time, because how long, once we find this time, multiplying this time with the velocity will give us the distance, right? So that will be v times t, right? Will be the answer for part B. Is that clear to you? Correct? Since the horizontal velocity is not going to change in this situation, right? So keeping this in view, let us now answer the question one by one. So what I've done here is simplified the question itself. There was a lot of content which can confuse many easily, right? So basically what we are looking forward for is, as I drawn earlier, let me draw it again here. We are actually looking into this situation when the tray falls from the height of 1.7 meters, right? So this height here is 1.7 meters, correct? In part A, we want to find how long would it take the tray to hit the ground, right? So the formula which relates to this, which you probably know, is displacement. This is the displacement, right? So let's call this distance d as displacement is equals to initial velocity. We say initial velocity by letter u, or you can say v0 t plus half gt square. Now g is 9.8 due to gravity, correct? Now we are actually considering the vertical motion. So in part A, we are only considering vertical motion. So in this direction, initial velocity is 0. Whatever velocity we have is a horizontal velocity. So this velocity is, we'll say VH. Horizontal velocity is 5 kilometers per hour, right? But the vertical velocity, which is along this y-axis, you can say, is 0. Displacement we know is 1.7. So we'll substitute 1.7 here. This is 0 times t, which will be 0 plus half. Value of g is 9.8, right? So we'll write 9.8 meters per second square, right? So, and then I've not used the units. You could write the units also. Okay. Now, and then we have here time t square. Okay. This is a simple equation to solve. We have 1.7 as equal to half of which is 9.8, which is 4.9 now, t square. So you can actually cross multiply. So you get 2 times 1.7 divided by 9.8 as equals to t square, correct? So that gives you the value of t as square root of, it will be always positive, right? So you can divide this by 4.9 and you can write this as 17 over 49. So that becomes the time, which is basically square root of 17 over 7 times 7 is 49. So what I did was, I did like this. I took away the decimals and divided 2 by 9.8, which gave me 49. Now 49 is a perfect square, 7 squares, so we could write like this. So these many seconds is your time duration. You can always use calculator to calculate this answer. So it is square root of 17 divided by 7 and in decimals it is around, well, let's write t as 0.589 seconds. So I'll just round this to 1 decimal place. So we'll write this as 0.6 seconds. Is that clear to you? Right? So how long would it take the tray to hit the ground? We get the answer, we get around 0.6 seconds. Is that clear to you? Right? So that's how we are going to answer this question. Correct? Now in physics, you should be including the units, right? So So basically, now let's look into the units part also. So this unit distance is in meters, correct? And then we have a unit of 9.8, which is meters per second square, and the unit of time is second square. Do you see that? So that is the unit for time, right? So meters per second square and second square, so they cancel away. So you have meters and meters to work with. Is that clear to you, right? So we have same units on both the sides, kind of balances out. So we get the solution for A, which is time t is equal to 0.6 seconds. Now let's look into part B, which is what is the horizontal distance by diving Lx? Now we know the velocity is 5 kilometers per hour, time is in second. We should actually convert this to meters per second. Now that's very, very important. So to do part B, first thing is we need to convert the units. So we are given this as 5 kilometers per hour. So 1 kilometer is basically equal to 1000 meters, right? So that meters will be now in the numerator, and in hours, we know 1 hour is equal to 60 minutes and 1 minute is equal to 60 seconds. So this is a very important part. You have to now again take care of the units, right? So kilometer cancels, hour and hour cancels, minute and minute cancels. So what you get here is basically meters per second. So that is very important. So velocity v is actually equal to 5000 divided by 3600 meters per second. Do you see that? So that becomes your velocity, which you could simplify, right? And you could divide both by 2. You get 25 over 18 meters per second. So that is the velocity. Now once you know the velocity and you know the time t is 0.6 seconds, you can get the answer. So the distance, horizontal distance, let's say, so horizontal distance traveled is what? Will be equal to this velocity into time, right? So that is what it is. So in our case, we get this as equal to 25 over 18 times 0.6. Do you see that? That becomes a simpler calculation to work with, correct? So that's what you get. That goes 3 times, basically 30. So what you get here is 25 over. So if you remove this decimal, it is 80, and so you get 30 here. So that is much simpler to calculate. I'm just trying to show you the calculations which could give you exact values. Dividing both by 5, we get 5 over 6, and the units are meters. It does make sense to you, right? So 5 over 6 meters is this distance. So we'll write this distance as 5 over 6 meters. Okay. Now, let's talk about the energy part, right? So energy at this time will be all kinetic energy, right? So it is 0 potential energy, and it is 0%, right? And 100% kinetic energy. It is all kinetic energy at this time. Here we had both potential energy plus kinetic energy. Good? So now let's calculate the energy at that initial point. It is going to be all kinetic now. So let's find this. So energy to start with was due to height, we say that is mgh, and due to the velocity, it is half mv square. Is that clear to you? Now the mass is 1.7, so it's a 1.7. Gravity is 9.8. Height is, the mass was 5, right? So, okay, height was 1.7. And now I'll multiply by 5 plus half of the mass here is the same, which is 5, and the velocity is this value, which we just calculated, which is 25 over 18. So 25 over 18 whole square. Correct? So that is the value, and the units will be joules, right? So let's multiply this and get our answer. So we get 1.7 times 9.8 times 5. And then we are going to add to this all this. So let's do this part first, which is within brackets 25 divided by 18 whole square. We are going to multiply this by 5 and divide by 2. So we get 88.12 joules. Right? So that is the value. You could actually redo the calculations and just check your answer. So we get the kinetic energy of the loaded tray just as it reaches the ground as 88 joules, right? So I hope we have answered the question. What you could also find here is the velocity with which the object or the tray is going to hit the ground, right? So that could be added here. So let me add a part of this question D, which is find velocity with which the tray will hit the ground. Okay. So let this be a question for you. So I hope you understand all the steps. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.